Okay, so let's talk about the third method for solving equations. It's called the elimination method. So the third method for solving a system of equations is called the elimination method. The first two steps of the elimination method are different than the substitution method. While the last 4 steps will be the same as the substitution method. Just looking at the name elimination, I hope we know that eliminate means to get rid of, make disappear, right? So the first step that we're going to use in this method is going to be multiply. Now, multiply is going to be an as needed step. So sometimes you're going to need it and you're going to multiply one or both of the equations, and sometimes you won't need it at all. So multiply. So if needed, multiply one or both equations to create a set of additive inverses between the two equations in the system. So in order to eliminate in math, we want to create that 0 when we're doing adding and subtracting. The two items have to be additive inverses. So for example, 3 and negative 3 are additive inverses because when we add them together, 3 plus negative 3 equals 0. So that is what an additive inverse is. You've also been using a lot of them when you solve equations. So if needed, multiply one or both equations to create a set of additive inverses in between the two equations in the system. Are being solved. In other words, when the two terms are added together, the sum will be 0. That's what it means to eliminate. Step 2 is going to be eliminate. Eliminate a variable by adding two equations together in the system. Then again, just a repeat of the steps from substitution. Step 3 is going to be to solve, right? Step 4, after we solve for that first variable, we got to find the second variable. And we need to write the coordinate point, that's the solution, or could be a special case where it's no solution or infinite or all solution. And lastly, we need to check our work to make sure that whatever solution we came up with, when we substitute that information back into an original system, that it creates a true statement. If we do that and creates a false statement, then we made an error somewhere and we need to go back and recheck our work. So let's go ahead and start applying these to some of the examples. And we're going to go through examples that have to deal without multiplication, so without that first step being used, and other ones that do. So if we move on to the first example, we have x minus 1 equals 1, x minus y equals 1, and x plus y equals 3. So I kind of look at this as columns. So I have a positive x and a positive x. Two positives, not inverse. Here I have a negative y and a positive y. Here, these are additive inverses because they have the opposite sign. And if I try to add them together, they're going to create zeros. So what I do, I'm going to insert Over the line here so you can see. So I'm going to kind of column this off. So when I'm adding this together, I'm going to add this vertically based on what the stuff is. So I have one here, and one here. So I don't need, multiplication is not needed in this step. So what I do is I go x plus x, and that's going to give me 2x, and negative y plus positive y, that's going to eliminate, and 1 plus 3 is going to give me 4. So 2x equals 4. Now I have a one-step equation that I'm going to go ahead and solve for by dividing both sides by 2. And I'm going to get x equals 2. Now once I know the value of x, I choose one of the equations up here. It doesn't matter which one. I'm going to choose the bottom one and do 2 plus y equals 3. Because I know the value of x is 2. So to get y by itself, I'm going to subtract 2 from both sides, and I'm left with y equals 1. So I've done step 2, which is eliminate. I eliminated the y's. I'm left with 2x equals 4. I solved, and I got x equal 2. I put that 2 back in to solve for the second variable, which is y equals 1. So now I'm ready to write my coordinate point, which is 2, 1. And last step, check your work. And I'm going to use the other equation that I didn't use when I was doing second variable. So I'm going to use the x minus y equals 1. So x 2 minus y of 1 equals, according to this, 1. And 2 minus 1 is 1. So this is true on the check. So I know my answer is correct. I can go ahead and list that answer over here in the solution section. 2, 1. I'll put some extra room there that I didn't need. 2, 1 is my final answer to the solution. So again, in this example, no multiplication was needed. I simply added things together. Example 2, I have x plus 4y equals 11 and x minus 6y equals 11. Okay, so this one, multiplication is needed. And so I need to decide, is my goal to eliminate the x's or the y's? In looking at this, the x's have the same coefficient. They have a coefficient of 1. So the only thing I would need to multiply by is negative 1. So in essence, I'm going to flip the sign of one of the equations. Doesn't matter which one, I'm going to do the bottom one. So I'm going to take negative 1, and I'm going to multiply it by x minus 6y equal 11. And we've learned previously that when we multiply or divide by a negative 1, what happens is the sign of each term flips. So this becomes negative x plus 6y equals negative 11. So once I do that, I'm left with a system again of x plus 4y equals 11. And now I have negative x plus 6y equals negative 11. That's what I changed the second equation to be. So if I go ahead and put in some lines, I'm looking at this horizontally. I guess not horizontally, I'm looking at this vertically. So x plus negative x is going to eliminate that variable. And now I have 4y plus 6y, which is going to be 10y, equal to positive 11 plus negative 11 is going to be 0. So again, even if I divide both sides by 10, I should recognize that in order to get 0, if 10 times y equals 0, then y must equal 0 as well. So I come up with a value of y equals 0. I choose one of my original equations. Now this down here, negative x plus 6y equals negative 11, that's not an original equation. These are your original equations. This is what you want to use. Choose one of them. It doesn't matter which one. So I'm going to choose the top one. So I'm going to have x plus 4 times 0 equals 11. So 4 times 0 is going to be 0. So I'm going to wind up with x equals 11. So now I have my two coordinates, 11 and 0. And I'm going to substitute in now into that second one to make sure that I'm accurate. So I would have 11 minus 6 times 0 equals 11. And that is a true statement. I know my answer is correct. And my answer is 11 and 0. Okay, so this was a real basic one in terms of multiplying, where I just multiplied one of the equations. And, really I was just doing it by a -1 to flip it. So that's kind of like, some people actually look at this instead of multiplying an equation by -1, they look at it as subtraction, because subtracting and this whole thing would be grouped together, then you would have to flip the sign of everything. So it would still result in the same answer. So first one, no multiplication was needed at all, and we got our answer 2, 1. Second one, we just had to multiply by a negative and essentially flip the sign of one of them so that we can create that additive inverse in between the x's. So now we're going to move on to the third example. And in this example, we're not going to be able to multiply by -1. We're going to have to multiply by a number. So I have 2x plus 3y equals 6 and x plus 2y equals 5. I can choose to multiply either equation. It doesn't really matter. I want to look for the easiest way, though, to match something up. So if I multiply something by 2, it's not going to get me to 3. I mean, I have to multiply by a fraction, right, to match these up. And who wants to multiply by a fraction? So if I multiply the x by something, like, well, I would have to multiply everything, but here, because x's coefficient is 1, I know that's going to be the easiest to multiply, or to change, because anything multiplied by 1 is itself. So it's very easy to control what you're going to multiply by. So I'm going to take this second one, x plus 2y equals 5, and I'm going to multiply it by -2. By doing that, I'm going to create an additive inverse between the 2x up here and what will become a -2x in the second equation. So I'm going to take -2 and multiply it by x plus 2y equals 5, because remember, you can't just multiply one term, you have to multiply everything. And that gives me a -2x minus 4y equals -10. Okay? By doing that, I now have, I still have the original for the top one, 2x plus 3y equals 6. Now I can line that up with -2x minus 4y equals -10. And sometimes people here, they will put, instead of subtracting, they will put plus -4y, because when we line stuff up, it might make their life a little easier. Take some space there. So I'm going to put in my lines. And I'm just controlling D to create that other line. And you don't need to do this while you're doing the work. I'm just doing it for a visualization effect. And now, when I add these together, 2x plus negative 2x is going to create a 0. So that's going to eliminate, leaving me with 3y plus negative 4y is going to give me a negative 1y equals 6 plus negative 10 is negative 4. Of course, I want to know the value of y, not negative y. So I can multiply or divide both sides by negative 1. And I'm going to wind up with y equal to positive 4. And so that's me solving for the first variable. Now again, I'm going to go back to an original equation. These are my original equations. So because I know the value of y and x is kind of isolated here, I'm going to use the second one to help me find the value of the second variable, which is x. So I'm going to have x plus 2 times my value of y, which is now 4, equals, I believe it was positive, yeah, 5. See the difference? Like, I don't want to use that 10. I'm going to use the original. So x plus 8 equals 5. I'm going to subtract 8 from both sides to isolate that x. And I wind up with x equals negative 3. So right now, my solution is negative 3, and my value for y is 4. So now I'm going to go back and put it into an original equation I didn't use. So I didn't use the top one, 2x plus 3y equals 6. When I say I didn't use it to solve in second variable. Okay, so by switching it up, I ensure that the solution I have is going to be a true solution for both equations in the system, because that's what I'm looking for. I'm looking for the in common solution, if one exists. So when I plug that back in to the original, I'm going to have 2 times negative 3 plus 3 times 4 equals 6. So now I'm just doing the math. 2 times negative 3 is negative 6. 3 times 4 is 12 equals 6. Well, negative 6 plus 12 is positive 6. So I do create a true statement, and I know I'm correct. So my final answer here is mistake. I'm going to kind of scoot in first. Negative 3 and 4. So in this example, I had to choose one of the equations to multiply by, and I had to multiply by something greater than 1. And I chose the second solution because the x here, it has a coefficient of 1, kind of making my life easy. Now we're moving on to the last example where we're going to need multiplication, and we're actually going to need to multiply both equations. So when I look 5x and 3x, there's no good way to multiply, just one of them, to multiply 3 to get to 5 or 5 to get to 3 while using a whole number or an integer. Same thing between 2 and 3. So I need to choose. It doesn't matter which one I choose. I can do the x's or I can do the y's. If I want to match up the x's, I'm going to multiply the top one by positive 3, and I'll multiply the bottom one by negative 5. I could also conversely multiply the top one by negative 3 and the bottom one by negative or positive 5. It doesn't matter. I'm trying to create, one has to be positive and one has to be negative in order for them to be additive inverses. Or 2 and 3, I can multiply the top by 3 and the bottom by negative 2. It doesn't really matter. I'm going to go for the y's because I like to keep my numbers as small as possible. So in this scenario, I'm going to multiply the top by 3. And that's going to give me 15x plus 6y equals negative 9. Now I'm going to multiply the bottom by negative 2. And I'm using a negative number because I need to create that inverse. If one was already positive and one was negative, then I could also multiply this by a positive number. But in this situation, there is no situation where I have a set of variables that have opposite signs. So negative 2 times 3x plus 3y equals 9. If I multiply that by negative 2, I get negative 6x. I'm going to do a plus negative here, plus negative 6y. So I created that positive 6y, negative 6y scenario, equals negative 18. Okay. So I'm going to change my color real quick just so we can see like the new equations right now. So the new equations I've created are 15x plus 6y equals negative 9 and negative 6x plus negative 6y, or we can look at that as subtracting 6y, equals negative 18. Again, I'm going to put a little bit of space here so that I can put in some lines. Okay, so now looking at this, go back down, I'm going to switch back to my blue. 15x plus negative 6x is going to give me 9x. Positive 6y and negative 6y, those are going to eliminate because they're additive inverses. And negative 9 plus negative 18 is going to give me negative 27. By the way, when I look at that negative 9 and negative 18, what I see is 1 9 up above, and then 18 is 2 9. So really 9 times 3 is 27. That's how I can do that quickly in my head. We're going to divide both sides by 9. And I'm going to come up with x equal to negative 3. So again, when I go to plug this back in, I can't use any of the red equations because those aren't the originals. That's something I created. And what if I had made an error? What if somehow I multiplied negative 2 times 3x and I wrote it down accidentally as negative 5x, right? That would create a situation where I get an answer, but it's not going to be an answer that's going to work for both equations, or maybe not for either equation. So going back to the original, I pick either 5x plus 2y equals negative 3 or 3x plus 3y equals 9. I don't really see an advantage of using either one. So I'm going to start with the top one because then it's like top for the first one and bottom for the check, and it makes my life kind of easy. So I have 5 times negative 3 plus 2y equals negative 3. Because the original equation was 5x plus 2y equals negative 3. So negative 15 plus 2y equals negative 3. And once I do that multiplication, I'm left with a two-step equation. So I'm going to add 15 to both sides. And now I have 2y equals 12. Divide by 2 on both sides. And I get y equals 6. Okay, so now I need to move on to the second. I have the second variable, so I need to write my point. So right now I believe it's negative 3, 6 is my solution. And I'm going to substitute that into the second equation. So I used the first original to do variable 2 or second variable step. And now I'm using 3x plus 3y equals 9 to check my work and make sure that I did it correctly. So 3 times negative 3 plus 3 times 6 equals 9. So 3 times negative 3 is negative 9. 3 times 6 is 18 equals 9. And sure enough, we get a true statement. So my answer that I came up with, my point, is correct. All right, jumped me out of there here. Again, I'm just going to take away some of this space in here so it doesn't knock me out of the box. My answer is negative 3 and positive 6. And those are my final examples. I've kind of given you the 4 different types of problems that you can see as you're solving systems of equations using elimination and recognizing whether you need to use multiplication or not. You have some additional GPs to do, GP 6, 7, and 8 that are on the following pages, and hopefully we'll get to be able to do some of those in class.